10 volts, same switched voltage here. Then these voltage are reaching to this point. Output of this rectifier, these voltage are reaching here at VCC capacitor. Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In last video, video number 1144, I repaired this 150 watt LED power supply, 24 volt. In this power supply, the problem, I detected that its VCC section was not working properly. Its transistor here, this transistor, diode, this diode, these two resistors, these were damaged. I received many questions from my viewers. Let's see these questions and I will try to reply them. I explain my own opinion. Might be it is right, might be it is wrong. So let's discuss. If you find anything wrong, I will request to add your opinion in this video. Video number 1144. I received comment. Really love these SMPS repairs, but can I ask how you knew what the diodes were, as no marking? Thank you. First question, diodes. That are these diodes, this one and this one. Then the next question, great video. Here is timestamp at 15 minutes where you find that it is NPN transistor. How do you know it is not a small MOSFET? This transistor. My viewer is asking, how do you know this is transistor? As its original transistor was damaged. That is this one. Can you tell microscope? It has great image quality. Yes, I am using Endon Star microscope. You can use 4 megapixels and you can connect also HDMI cable. To decrease the video size, I use just only in 2 megapixel. Quality is really fantastic. It is Endon Star AD407 Pro. Then very informative video, thank you. Sir, when switching MOSFET high power and also short, dangerous for lithium. This is another question. Very nice. Your scientific knowledge is very high. Thank you. Which one temperature should I use on power supply PCB, 250 degree centigrade or 350 degree centigrade? It depends on the IC. Which type of IC we are using. Sometimes we need 250 degrees for 10 seconds. Two things are very special. The first, when we see data sheet, we can see lead temperature and soldering time. For example, 250 degree centigrade for 10 seconds, 320 degree for 5 seconds. Some ICs can be soldered at 380 degrees for 3 seconds. Depends on the IC structure. So always consult the data sheet for its lead temperature. Which one soldering iron fine to soldering PCB components? 30 watt but does not desolder. Soldering iron. If you are using 45 watt, it's good. And for power MOSFETs, sometimes we need 60 watt soldering iron. Could you please make a video about barcode scanner? I will try to arrange. Then this comment from Jalal76. Good job, thanks. Then Hisham from Morocco. Very interesting pathfinding technique. Useful parts completely damaged. What does resonant means? Resonant circuit, it is a topology. Then very informative videos. NPN transistor is confusing me because it's connected before the load. Yes, the same question we will discuss now. I behind on how to identify SMPS Zener diode. Sir, I am following you very long time. Why don't you prefer the SMD hot air gun to remove SMD components? Your work is really awesome. Yes, I have hot air gun. I have complete rework station. It's Weller WR3M. But most of the time I love manual soldering. Hot air soldering I just use for a special job. Otherwise For normal routine work, I use soldering irons. I feel comfortable while working with soldering iron. Thanks for sharing video. Can you explain in more details PFC circuits and how we know it is working? This subject also needs a complete detailed video. Thank you and have a great weekend. Thank you. Sharing knowledge to us is great. Thank you. God bless you, my dear brother. Thank you, brother. Hello, Hasib. My name is Muhammad Ashraf. Hasib is my youngest son. What a professional job. Can you tell me this timestamp? How to know if it might not be a Zener diode? We have theory. There is no problem to detect fault. I read some comments. I think Hasib is your firm name. No, Hasib is my youngest son. I am blessed with two sons, Muhammad Zain and Muhammad Hasib. Hasib is the youngest one, so my both channels are named to Muhammad Hasib. Hasib Electronics and Hasib Electronics Urdu. Your good name is Mr. Ashraf. Yes, my name is Muhammad Ashraf. SMD resistor book. Yes, SMD resistor and capacitor book. That is really fantastic. It's around $17. That SMD resistor package book is fantastic. We must understand the circuit theory. In this section, it is SMPS controller, resonant converter. Here is PFC circuit. There are different techniques to control PFC controller. For example, if we have standby section, PFC, SMPS section, power stage, there is another stage that is called standby section. Standby sections takes line voltage to rectify and that generates a separate power supply to power on these chips. That is a method. Then how to control the PFC controller? Will it turn on all the time? Will it load dependent? When load will be connected, at that time this IC will become active. If line voltage are high and there is no load, that time this PFC controller must remain off. So there is a supply switch that is called VCC switch for these power supplies. This IC set L6599 and L6562. This configuration is commonly used in different LED circuits, DVD circuits, DVD players. In this power supply, in this LED driver, there is no standby section. In this technique, first it will rectify the voltage. It will maintain voltage on this capacitor. If 220 volt are applied, it will maintain 310 volt here. Then it will start converting voltage here. It will drive this transformer. When it will start to maintain voltage on this capacitor for initial startup, this point, it is PFC section, voltage reaching here. Then this resistor 330K, 330K, these two resistors in series, and this point is reaching to this VCC capacitor positive terminal and this pin. It is pin number 12. Pin number 12 of this IC is supply pin. When positive supply will reach here, this capacitor will start charge, this IC will take start. When it will start, it will switch these MOSFETs. When it will switch, at that time, it's these two center windings, this one and this one. This end is connected to ground at this terminal. If we check second winding, this end, this point, it is connected to these resistors. Then this voltage will reach here, and here is diode. When we have transformer output connected to diode, in this side, when I was removing, I made marking here that this is cathode side. From cathode we receive positive voltage. From cathode of any rectifier we receive positive voltage. Here is capacitor. So we will receive voltage, positive voltage here. End of this capacitor is connected to ground terminal here, primary ground. So I can say this end is grounded of the auxiliary winding, and here is actually 22 ohms resistor in parallel, but I installed 20 ohms resistor, so it is 11 ohms in parallel. I will write the original value 22 in parallel. I installed 20, so it is around 10 ohms. Actual value 11 ohms. Then I have this rectifier. In SMPS power supplies, in switching power supplies at low current, most commonly it is used 1N4148 diode. That is fast switching rectifier. For low current application around 150 milliampere, 200 milliampere, maximum 150 milliampere, 1N4148. When we see these diodes with black ribbon, that means it is a simple diode. Fast switching rectifier. In high frequency switching applications, most of the time the diode 1N4148 with black ribbon. Now we have this capacitor. This end is connected to primary ground. Now we have positive voltage here. If we see 1 kilo ohm resistor, it is connected to base. This base pin. When it is reaching to base and this end is more positive, it is directly connected to supply pin, positive voltage. And this voltage dropping resistor, it will provide base biasing. Basically it is working as a switch. One kilo ohm resistor. What is the diode here? Because it is working like a switch. Logically, here must be a simple rectifier to provide base to emitter level, that when this power supply will reach here, it will just allow a controlled current to base to emitter to turn on this transistor. Sorry, it is not connected here. This end is grounded. Now we can see it is connected in reverse polarity. This is now output point. This is emitter point. Emitter point is connected here. Then it is coming to this rectifier. And this rectifier is connected to VCC capacitor. We can say initially this IC will take start from this side, 330 kilo ohm, 330 kilo ohm, 660 kilo ohm resistor in series. It will provide slow charging current to this capacitor to provide soft start. Then it will receive this supply at this point. Now this separate power supply is reaching to this capacitor, that is VCC capacitor for L6599 PWM controller. From emitter, this point, and output from this rectifier, it is one-way conductor. Supply will reach here. We will receive VCC voltage at this pin. Now the same point, this point, it is also connected to this point. Output of this transistor is reaching here. This end, this is also one-way conductor. It is reaching to this VCC pin of this IC. We can say from emitter we have two paths. These one-way conductors are normally 1N4148 diodes. It is going to capacitor, and this is VCC for L6562. In some circuits, here is 16 volt Zener. If we connect a simple diode or we connect Zener, it will the same. If I remove this transistor and I make jumper from this point to emitter, it will pass the voltage here. We will disconnect this transistor. First I will apply power and we will check it, and then I will remove this transistor. Now let's see an example here. The same configuration here in this circuit. It is power supply circuit diagram for Philips K1502. Let's come to this section. This is auxiliary winding, pin 7 and 6. Two resistors, 4R7, 4R7. These two resistors are used here. Basically these are to adjust the voltage, depends on the transformer winding size. Then this diode, BAV21. It is similar to 1N4148. Then these voltage are passing to this transistor. And here is optocoupler. It is a remote turn on switch. When this optocoupler will turn on, it will bias up this resistor and these positive voltage will pass to this assignment. Same as I discussed here, we have one transistor here, one resistor here, and here is 16 volt Zener. If we have 16 volt Zener, or if we are using simple diode, that will be the same. Then positive voltage will pass through this transistor and it will provide VCC to this IC. Pin number 8. It is the same configuration. Now let's power it on. If you don't have good experience in electronics, never do this experiment because we will apply live voltage here. Always take care for the safety. This is ground point and we are receiving 10.6 volt at collector. At emitter 10.1 volt, 10 volt. At this rectifier 10 volt, same switched voltage here. Then these voltage are reaching to this point. Output of this rectifier, these voltage are reaching here at VCC capacitor. Then these voltage from this point to reaching this one-way conductor. Then these voltage are reaching to second side 9.8 volt to this IC. PFC controller. Now it is turning on directly. If you see this circuit, there is an other transistor that is configured with optocoupler. So it is remote on. When remote on command or any power switch will turn on, that time its PFC circuit will start. Normally PFC circuits will remain off. It is basically a series switch. Now I will remove this transistor and I will turn on this circuit without this transistor. We can use NPN transistor here, and then I will discuss how I assumed that it is NPN transistor. Why I did not use any MOSFET or any PNP transistor. Now I will pass these voltage directly to emitter pin. I disconnected the base pin. I will turn on this circuit without transistor. What will happen in this case? If we are doing this practice, in this case might be the VCC pin here will obtain slightly higher voltage. At that time we can adjust this resistor value. We can increase a little bit resistance, but most of the time there is no need to increase the resistor value. .4. Here is now 10.04 volt. We can say 0.2 volt increased now. That is not a big difference. If we need to decrease the voltage, we can decrease the voltage by adding a resistor value. For example, here is 10 ohms now. We can make it 15 ohms. Now let's discuss why I selected NPN transistor. Always discharge this capacitor. In this footprint, this pin is positive voltage pin and this is control pin. Either it is gate, if you can say this is MOSFET, in that condition this is gate pin, and this is source pin. For example, if we say it is MOSFET, if I say transistor, then this is emitter pin. Footprint will in this shape. Tab, emitter, base, collector. Positive voltage are connected to collector pin and we are taking output from emitter. Then we have two diodes that are isolating this section and this section. For example, if this IC is taking start, that positive voltage will not reverse flow to this IC. So this IC will turn on when this section will turn on. First here it will take 330k positive voltage line. Positive voltage will reach here and it will turn on this IC. It will switch and it will generate voltage in this primary winding, and that primary winding, this is output winding. This IC will drive this section. We will take output here. When this output will come here from this switch, it is just only, we can say, safety switch, series pass switch. There is no regulation required. So that is the reason I used only just simple diode. We can also use 16 volt Zener diode. That is also extra layer of safety. Otherwise, if we connect simple diode, it will work normally, because its maximum supply voltage are 10 volt, 11 volt. So if in any case, if this voltage will increase too high, this will damage. We have many safeties in path. Then PWM controller will control the voltage, because in each case it will adjust the voltage here. I hope you enjoyed this video. If it is good, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.